started. We are working through integration by parts. Before we get officially started on my first question I want to do, there is another technique for doing it. It's the UDV method. And if you look online, you'll find it. It's a very common method. I don't like it personally, but that doesn't make it wrong. So if you want to have a look at the UDV method, feel free to do so. I don't show it. One, I don't like the method, but that's not a big deal. A lot of things I don't like or I probably should like. But I don't like showing two methods to do one thing, because all that does is confuse students most of the time rather than help. Or God forbid, they take a bit of the first method and a bit of the second method and they make a Frankenstein method that doesn't work for any of them. So, you know, one method all the time kind of simplifies the game. But if you want to do it in the test and you want to do the UV method in homework, feel free. Okay. Deja vu. Have I done one like that? So I've got a lot I want to get over today and I don't want to repeat myself. Do you recognize this one or is this new to you? I can't hear anything yes or no yet.
You did a similar one yesterday that was 3x times e to the x.
Okay, so this one I think is different, is not different enough. But as I say, it's not like you're not going to get practice. Let's do this one. Right. So here's our guy. I need to identify who the f of x is going to be and who the g of x is going to be, right? That's what I called, I believe, step one yesterday, right? In this question here, which piece of the two things multiplied is f?
X squared plus 3x.
Right. And obviously whatever the other piece is our g. Now, if you differentiate this fella, you get 2x plus 3. And if you integrate, find the antiderivative, you get negative cosine x. Are you all happy about the negative cosine x there? Remember, it's an integration technique, right? Antiderivative. Now, you put the package together, and I'll call it this guy because it is. And we have this fella. Take away this fella, right? So it's f of x goes here. Capital G of x, which is this fella. Oops. Take away the derivative, which is this fella. Capital G of x, which is this fella. D of x. And then I'm just doing a little bit of tidying up. I don't like negatives and cosines, so I'm just separating them out. Are you all happy about that and that are the same thing? Just subbed out a negative. Now this negative can come outside and join that one, so I now have a positive, and I have a 2x add 3 cosine x dx. Now, sometimes we are almost finished, right? Wouldn't you normally find this integral and then we'd be finished? But sometimes don't you have to repeat the process? So is this integral ready to be written down, or will I have to use integration by parts on it? Can I just write the integral down, or will I have to do integration by parts? Right. So what I tend to do is separate out that question. And when I get the answer, I'm going to write it here. And I separate it out and I do it over here like on scratch paper. And now I need to find my f and g again. Do you know it sounded like I was swearing there? I'll need to find my f and g again. No, I don't swear, right? Often. We get this guy, and we get this guy. And I wrote them down without asking, but I hope you would have picked those two. Now the derivative is a 2, and the integral of this guy is a sine x. Although you've only done a few of these, do you notice that the f that you pick keeps on getting simpler and simpler as you go through the process, but the g tends to just be pretty ugly all the way through, right? It never gets better. That's a very common feature of this technique, that the f gets simpler and simpler and simpler until you don't need to do any more integration by parts, because the bit that's left is an integral that you know. Now, in this case then, we're going to do, and I'm writing down much more than I suspect you would, and that's okay. But you got to think of these questions, or at least the way I'm writing these questions, is a way to show you the process like a template, so you can say, okay, what did he do? What did he do? Because sometimes if you miss out a line, you'll go back and you'll say, what did he do? Right? How did that happen? Now, in this case, 2x add 3 with the sine x, take away a 2 with the sine x. And you know that you've finished when this guy at the end, right, the integral bit, you know you've finished when you know the answer to this one, right? You don't need to do anything else. You know what it is. So in this case, I have 2x add 3 sine x, take away. Would you agree that you know how to get the integral of 2 sine x? Won't that be negative 2 cosine x's? And 2 negatives make that a plus. So this answer goes here. Well, we're 90% finished. I wouldn't say we're 100% finished, but we're definitely 90% finished. What do you think I need to do now? Style points, essentially. What do you think I need to do now to make it look pretty? That's not good.
Would you multiply like the
Yeah,
x
distribute.
squared
Yeah,
and- yeah, distribute.
distribute everything inside. Now, looking at that, that looks quite pretty. So you might be thinking, why bother? It looks pretty nice. But it does have some cosines and some sines that I would want to put together. Do you see this guy here? Would you agree that you could probably join this guy here? So I could just distribute it all and then collect like terms, which would work. Or I could notice this too. And I'm going to write something down that looks wrong, but it's right. That negative 2 looks wrong because it used to be plus 2, didn't it? Why is that negative 2 actually correct? You see this negative?
Oh, because you have the negative sign on the outside.
Yeah, so 2 negatives make a plus. That's probably not going to happen. That might be the only time that's going to happen. But you make it look pretty. Now, I don't know how generous WebAssign is. It may be quite happy with the answer, and that's fine. I guess if it's happy, we're happy. But, you know, I like things just to be, you know, a little bit prettier if we can make it. I don't know if I can sell this on you. Would you agree that's slightly nicer looking than that? I mean, it's not a huge improvement, but it is better, in my opinion. Are we comfortable with the process of how you do integration by parts? That you've got a function made up of 2 things multiplied together. One of them is going to be called f, the other is going to be called g, and you just go through this 3-step process until you're left with an integral at the end that is a doable one, right? One you know the answer to. Excuse me. Are we good?
Can I recommend a problem that we can try?
Go for it. Which one? I might hold off on it, but I will do it.
Okay, yeah, it was one on the homework. It was natural log of x and then in parentheses squared.
Yeah, I will do that one.
Okay.
I'll actually take a little note so I won't forget. And we'll show you how to tackle that. But that, I don't know. I think I'll do one more, if for want of a better word, typical, no weird integration by parts. And then we'll start looking at the weird ones, right? Questions
Okay.
that don't look like they're integration by parts, but actually are done using that method. So one normal kind of one, right? This is a version of question 3. We'll do the integral of t, the sine 2t dt. So, okay, this one is pretty much a straightforward one. Again, I just want to add a little bit later to this one. Would you agree that f of t is t and that the g of t is the sine of 2t? Are you all comfortable about my choice of f and g? The derivative here is 1, and the antiderivative of this guy we can do using the linear shortcut method. Now, if you integrate a sine, you get a negative cosine. So if you integrate the sine of 2t, you get a negative cosine of 2t. And I've done this a few times. You also get something else, don't you? Because the 2t.
1/2.
Right. Are you happy about the antiderivative of being that? If you're not, couldn't you do a little baby u sub question and eventually get the answer? So we're going to do f of t, g of t. It's going to be f of t, capital G of t, take away f dashed of t, capital G of t, dt. Now let's see what we get. We get a t, and we got this guy. Take away, we get an f dashed times this guy again. And then I try and make it look pretty. If you multiply that together, you get negative 1/2 t cosine of 2t. Two negatives make it a plus, and you end up with 1/2 the cosine of 2t. But that is doable, isn't it? I don't need integration by parts to find this fella. Can't I just do another version of the linear shortcut method? So it's negative 1/2 t cosine 2t. If you integrate 1/2 cosine, you'll get 1/2 sine. So integrate 1/2 cosine 2t, you get 1/2 sine 2t times another 1/2, which is why that's now a quarter. Now, typically in these questions, you put c, but sometimes they do that. Okay, so how do you cope with that? Well, you really don't do that much on it that's unusual, I would say. Right, there's the guy. Don't you just evaluate it at t equals 0 and t equals pi? In other words, you don't have a c, right? Does that make sense? You just do the same process, but you plug in some numbers. Now, in this case, it's going to be negative 1/2 pi, the cosine of 2 pi, plus 1/4 the sine of 2 pi. That's the first piece. Subtract. If you put 0 in here, you just get 0, and you put 0 in here, you just get 0, so you get a whole load of zeros. Almost finished. The exact value for the cosine of 2 pi. Exact value of the cosine of 2 pi.
One.
Yeah. And the sine of 2 pi is nothing. So, whoops, more brackets than I need. So negative a half pi times 1. And your answer is negative a half pi. It's okay to be negative. You know, integrals can be negative, right? Area under curve can be negative. Okay, integration by parts when there is no limits of integration, put a plus c. Integration by parts where there are numbers, do the exact same thing, but then plug in the start and finish values and evaluate. So that's the only difference, right? They're pretty much the same kind of question. Now, not forgot about the log, what is it, log x squared? Yeah. But let's do what looks like an impossible question. So I'm going to do this one first, and then I'll do the log x squared. How can you use integration by parts when there aren't two parts? There's only one function here, log x. Well, you kind of cheat. You call it 1 times the log of x. Second cheat, not so much a cheat, but the second part is pick the log of, pick, in this case, the log function, right? The function that's on its own. Pick that as the f, and pick the 1 as your g. Okay. What's the derivative of natural log of x?
1 over x.
Agreed. What is the antiderivative or integral of 1?
X.
Are you all happy about that? Right? The f and the g, stick in a 1. So you will use this if you ever get a question that's like the integral of inverse sine of x, the integral of inverse tan of x, the integral of log x, the integral of some function, but just one function, right? Log x squared, right? Which is the next example, right? Call it 1 times the other guy, make the g 1, and make the thing that you're trying to get the integral of, make him f. So now we can do the integration by parts. Now you might be a little bit suspicious that this isn't going to do any good. Well, let's see if we can convince you that it does. Log x times x. Take away 1 over x times x. Make it look pretty. X's tend to go before logs. Oh, wait a minute. Won't 1 over x times x just be 1? So what you're really looking at you got your answer. So the integral of log x is actually x log x minus x. Where's my standard integrals? I got a table over here somewhere. It's very messy. Right, here we go. Not quite sure where to put it here. The integral of log x is x log x minus x. So if in the future I need to find the integral of log x, won't I go to here and use that answer? I guess I could do this to, get it if I forgot. But would you agree that's probably a nice integral to know the answer to? So if you think it's a nice thing that you might want to do, then you should do it. Now, I'm not sure what the question number is, but I do know what the question is. Do you have handy what that number is, Sean? I think it was Sean that asked.
Yeah, I don't. I can like look quickly.
I
if you
can. I
want.
got it. I can look for you. I just
Okay.
thought you might have had it handy. It's version 8. Now, I know that says log x squared, but I don't want you to think of it as log x times log x. I want you to think of it as 1 times that thing. Okay? 1 times that guy. So my f of x and my g of x have to be chosen now. Based on what I said in a previous question, what will g of x be?
One.
In these situations, make it 1 every time, right? When it's a single function, a weird one, you would do that. Now, that makes all of this guy f of x. I'm going to integrate 1. That's easy. This will get some cobwebs out your brain. If you want to differentiate this guy, it's what we call the chain rule, right? A function of a function situation. So you get 2 lots of the natural log of x to the power of 1 times the derivative of the natural log of x. Are you all happy where the 2 log x times 1 over x came from? It's called the chain rule. So we can now do this guy. So it's f of x, capital G of x, take away f dashed x, capital G of x, dx. What do we get? F of x is this guy, G of x is x. So I'm going to get f of x times capital G of x. Take away the derivative. Ugh. And I'm going to make it slightly prettier, but not really that much. Looking scary. Looking, it ain't working. Okay, I don't know that answer, but that one's just as bad. This isn't going to work. Well, you're wrong. It is going to work. I just have to do integration by parts on this fella. He's a little bit different looking. So let's see who we got.
Did you forget the g of x on the integral
Oh.
part?
Thank you. Hey, it's making my job even easier. Because I get that, don't I? If I had to, I would have done integration by parts the second time and it would have came out if what I thought was going to be the answer would do it. But this is nicer. Do we know the answer to log x? Yeah. I just wrote it down here in case I need it someday. And guess what? Someday has arrived. There's a 2 there, but won't the 2 just mean you stick 2 in front of your answer? So I have this fella, take away 2 lots of x natural log of x, take away x. And although you can't really do any meaningful style points, I still think it is worthwhile to do that. Do you like the sneaky way that we get round the problem? Let me do another question involving a log, because there seems to be quite a few of them. This particular question is number 10. And I don't think there's any change to it. So it is, everybody's getting the same question. Now, if I was doing an earlier question, right? Remember the question that looked like that? Didn't we just stick a 1 in there and go off and do what we needed to do? In this question here, you could do that same process. And eventually, it would work, right? Eventually, you would get it. But you'd have to do some really ugly chain rules and derivatives that don't look pretty and all sorts of, lots of places where you could go wrong. So I am going to do a shortcut. Remember the rule that says, oh, in case you're wondering, isn't there a rule that says a square root is a half power? And then there's a different rule that says a power can come out as a multiple. You see where that half came from now? So this question, which would have taken maybe, I don't know, somewhere between 5 and 10 minutes, is actually this guy. But wait a minute, don't I already know the integral for the log of x? It's x log x take away x. So a half of them will be 1/2 of x log x take away x plus c. I don't know, it looks kind of pretty like that. What do you think? Do you think it looks slightly prettier like that? Yeah, it's just style points now. You notice how simple that question was once you realized it could be written like that. I wish they'd done this question. What fractional multiple of log x will that guy eventually be?
2/3.
Because isn't that guy 2/3? Now, once they got there, wouldn't it just be 2/3 of this answer and you're finished? So if you can see it, use it. If you can see a shortcut, do it. If you can't see a shortcut, make that 1 times this fella. The f of x will be the natural log of the square root of x. The g of x will be 1. And you will eventually get the same answer. Right? Eventually. Okay. You'll have to trust me on this. That's what the answer would look like if you went this route. Do you notice the only difference is there's a square root here and no half? There's an x here, but there is a half. That's what it would look like, probably. Are we good with that question? So if you get a single function on its own and there's some logs involved, these are the guys, these techniques are the ones that you're going to use. I'm still on functions on their own, so this is a version of 9. I'm not going to do theirs, I'm going to do the inverse sine one. But it's one function on its own again. This one is a little bit different at the end. It's going to be exactly the same process for the first half. The second half, something weird's going to happen. Right, it's a classic problem, isn't it? One function on its own. Yeah, I need to get its answer. It's a classic answer. Call it 1 times. Just in every other case, the guy that's on its own is inverse sine. and that guy is 1. Isn't that what we did in all the other times this happened? The capital G, the integral, is x. Oh, this is going to test your brain. What's the derivative of the inverse sine function? I'll give you a start. 1 over.
1 over the square root of 1 minus x squared.
You deserve a prize. Yes.
Yes.
You're not getting one. You deserve one, but you're not getting one. See, if you were in a physical class, I might have gave you some candy, because I like candy. But you're just getting a visual candy. Right. Are we comfortable about that's just a memory thing? I know what the derivative is, right? There's no proof to that. Well, there's none that you need to go into. So we are ready to see where this leads. Well, it's going to be f of x, capital G of x, and the integral. I like writing formula down because see if you write them down enough, don't you end up just inside your head now? You don't need to go looking for them. Like, I would hope most of you know what the product rule is without having to go and find out in the textbook what it was, right? You've used it so many times and you write it down so many times. Eventually, it just is in your brain. So it's going to be f of x, which is that guy, times capital G. Take away the derivative, which is this guy, times capital G, and make it look slightly nicer. I like to put x's at the front. And not so nice here. You would hope, and up to now this has been true, that shouldn't this integral just be doable, or at least nicer, and then you just do integration by parts a second time and it becomes doable. Right? When I mean doable, you can just write the answer down, right? You know what it is, right? I know sine x gets me negative cosine x, right? That kind of thing. What on earth am I going to do about this fella here? Which is the first time it's happened. How am I going to get that integral?
The substitution rule?
Oh, Jessica nailed it. I'll pause for a minute before we get started. Can you see what she's getting at? She's right. Like, what happens to people, and it's easily done, aren't you probably in integration by parts mode in your brain? Everything in sight is an integration by parts, right? And then suddenly this hits you. And what do? You go and try and do integration by parts on it, right? Because your brain's in that mode. And it just goes downhill really quickly. And you just go, oh, God, I don't know what's going on here. It's not integration by parts. It's a U-sub. Agreed? U-sub. So, negative 2x. Crossover. And finally, isolate the dx. So this guy becomes the integral x. Do you know this? Maybe I'm wrong. Was there a test question where you had to integrate something like that? Kind of reminds me of a test question. No. Maybe it's just me. Well, you get some cancelling. And you are looking at negative 1/2. I like to separate them out. That guy. Okay, where do you go next?
Change the u to the negative 1/2.
And I know that we've done 1 over square roots of all sorts of variables, right? So you'll certainly have seen that before. And now you can use the power rule, which means you add 1 to the power, right? And then you divide by the new power, which means you multiply by 2. So are you happy about where the negative u to the half came from? Because the half gets times 2 and they cancel each other out. This becomes that guy, which in turn becomes that guy. So I have just found what this piece is equal to. I'm about to do a deliberate mistake. What's wrong?
Should be plus.
Yeah, because this is negative and you've still got this negative. Do you see how easy it can be to lose a sign? It's subtract a negative. You go all the hard work, yay, got the answer, and then you forget to look carefully. And this is the answer. Is that cool or what? The one that you're going to do in question 9 is the inverse cosine of x, but it's very, very similar, right? So you won't have to change too much to do that. Right, for the few minutes that we've got left, I'm going to write down questions and who the F and G should be. So here is question 11. I'm not putting the numbers in, we know how to deal with them later. It's a log x squared over an x cubed. Now you might say, oh, I'm going to have to do an F and a G. I agree, you are going to have to do an F and a G in this question. But I don't think it's so obvious, but hopefully you'll be able to tell me. Who is the F in this question? What's your gut feeling? You don't need to be right, but what's your gut feeling?
X cubed.
Ah. Well, said you don't need to be right. That's going to be the one that works. Now, you could end up, and I'm calling that x cubed, but I forgot, it's 1 over x cubed, isn't it? If I rewrite this guy as this fella, does it look more like a product to you now? So if we call this guy x to the negative 3, does that help a little bit? Right. Now, if you had tried the other way around, wouldn't you have to integrate the natural log of x squared? Can you imagine that that would be a lot more work? It's much easier to differentiate it than it is to integrate it. Are we cool with that one? That's basically the last one of the F and G's on their own. So what's left? Well, there's a 2-stage to this one. I'm taking out the limits of integration. I'm just focusing on the main question. And you are being asked in question 12 to do a substitution first, and then an integration by parts after that. So they've at least told me what I need to do first. What U sub do you think you should use in this question?
Theta squared.
Theta squared it is, correct.
Okay.
So U by d theta is 2 theta. du is 2 theta, d theta, and when you isolate the d theta, you get that. Now that's going to become, and don't panic when this doesn't look right, it's going to end up being okay at the end. you would have probably thought, oh, the theta cube's going to go away and I'll be left with a cosine of some kind. Not quite. One of these cancel. Oops, by the way, got that right or wrong. I've got an orphan theta squared, don't I? I don't want thetas or theta squares. Don't I only want u's in this world? What can I replace theta squared with?
U.
So you are now going to be integrating this fella. Does this fella look like an integration by parts to you? He is. And I won't do any more than set it up. There's your two guys. A little kicker in the tail here. When you've finished this, won't that just be the answer in terms of u? Won't you have to remember to replace them by theta squared? So if the answer ends up being u cosine u plus a half u squared, you know, whatever, will you remember to turn all the u's into theta squares? Because the original question is in thetas, we expect your answer to be in the same variable, right? Plus in this question, you'll need to know it because there's limits of integration here. So that's a long question. How about this one? Which is question 13. It's going to have to be the last one for today. It also is a U-sub, they tell you that. Not an awful lot of choices here. Any suggestions?
Probably the 1 plus x.
It is. Doesn't look particularly promising, but it is. Which means I have an x, a natural log of u, and the dx gets replaced by a du. Okay, I got an orphan x. How am I going to deal with the orphan x? Because I need that x to be written in terms of u. How can I make that happen?
You do u minus 1.
Agree? Which means this becomes u minus 1 log u. Would you agree you now have an integration by parts question? And, oh, went red for some reason. That guy's your first one. And he's your other guy. And off you go. And again, will you remember to replace all the u's when you're finished with 1 plus x's so that you're completely finished? That's perfect timing.
I have a question.
Sure, go.
So last time when we just did the natural log of x, we made 1 the g value, and we made the natural log of x the f value.
Uh-huh. Oh, why did I do that? I apologize.
Okay, thank you.
I think I was just too much in a hurry to finish.
All right, I'll take a visual piece of candy.
Oh, you deserve 2. 1 for catching the mistake, right? And 2 for knowing what the right answer should have been. Okay, are we good with that? You know, if you keep track of the candy, when you eventually meet me, you can say, you owe me 9 pieces of candy. And just drop by my office. I always have a little thingy of candy. I'll give you 9 pieces. So Evan, you've got 2. Bezida's got 1. Has anybody else collected visual candy yet? Not really. I just started today. Right. Now, if you screw up, does that mean you owe me a piece of candy? Does it work both ways?
Okay, but you're gonna have to come over on Halloween to pick it up.
I probably won't. You're right. Okay, everyone, as I said before, will you make sure you say hi? And I'll hang about because I know there's some homework questions that at least one particular person needs some help on, but feel free for you to wait for them, to wait behind for him as well.
Thank
Good
you.
day, thanks.
Bye-bye.
Thank you.
Just waiting to see who's still here. Okay, so I think oh, Bryce is here. Okay. John, let's do you first. You've waited long enough. Right.
Okay.
What you got?
I'm checking the email again. So it's on 6.4. Or actually, I'll start with the recent homework, which was
Sure.
the average value of the function. I think is on.
Is that section 6.5?
Yeah.
Right. And what question
So-
number?
It was question 12.
Okay. Is it something you could just read out? Saves me having to go and find it.
Yeah. I know the answer to the problem. It's just it was one where you have to find the average value with b in the interval, like 0 to b.
Right.
And I was on my last try, and I accidentally put the larger value in the smaller value, and then the smaller value in the larger value.
Right. That's an easy fix. That you'll have to shoot me an email because my life is too busy to remember things.
Yeah. Okay.
And I can fix that.
Okay. And then on the other one, it was 6.4.
Okay.
Which I'll go to right now. And it was specifically for problems 9 and 10.
Right, can you give me 9 first? Because maybe if I fix 9, 10 will kind of be obvious.
Yeah. I mean, I've already actually, wait, no, I got 10 right. So it's just 9.
Okay.
It was for the Riemann sum
Right.
thing. So it kept saying,
oh, I know. This is one of these rocks getting pulled up a cliff kind of questions.
Yeah, it kept saying like my Riemann sum was wrong, even though.
Your answer is correct.
Yeah.
Right.
Yeah,
I keep
like
putting
the-
words in it. I know exactly what's going wrong here. When I did these questions, didn't I say, let's pretend a random spot X units from the top? Right.
Mhm.
That's typically the way I do it.
Yeah.
What they do is they count X from the bottom. And so
Okay.
your equation ends up being a different looking equation, but the same right answer because you're just looking at it from a different perspective. And that's what went wrong.
Mhm.
But it wasn't programmed well enough to realize there's 2 directions. And it only chose the bottom up version of X as the one it was looking for.
Yeah. Okay. That's confusing.
Yeah. People see things differently. I mean, I can
Yeah.
imagine doing it that way. I don't like it that way. To me, it's more natural talking about what's left to do rather than what's already been done. But, you know, different ways of looking at the problem.
Mhm.
If you really want to get confused, in some textbooks, they don't even call it X, they call it Y. That one I could get away with because isn't vertical kind of the Y-axis.
Yeah, I guess you can see it that way.
So it's only a perspective thing. So since I'm the person that actually gives you the points, if you got a situation like you know you're right because the final answer is right, so you must have done it correctly.
Mhm.
Again, on that same email, you just tell me, oh, question 9, part A, I got wrong, but I really know it's correct because I got the final total. Then I just go back and I give you the points that you would have got. Right, I'll just overwrite whatever sign. So that's how I will do that. And in a test, feel totally free to do it my way, even if the book or the question or WebAssign, whatever you want to call it, wants to do it another way.
Okay. Yeah, and it ended up being only problems 9 and 11 that I got like points marked off because like I got the right answer, but yeah, the wrong equation. So I'll just email you about that.
Yeah. So now that I know what your question is, it really wasn't. You weren't doing anything wrong. What you were doing was totally correct. It was just a different version of totally correct.
Yeah, yeah.
Right, that's all it was. So
Okay.
I hopefully that makes you feel better.
Yeah, yeah. I'll just blame it on WebAssign.
It's great. Blame it on WebAssign. I can't blame it on everything, but in this case, I would.
Yeah.
And I don't even know blame it. You know, counting from the bottom is correct. It's just a different way of doing it.
Yeah. Okay.
Okay. Right.
I'll email you about that later.
No problem. Any other questions? Well, we're kind of doing you first because of your long way. No. Anya or Bryce? Who's next in our little list? What do you want?
I'm a little confused about how to find which is f of x and which is g of x for the
Integration by parts?
yeah, integration by parts.
Okay, let's show you some situations. If you see situations where there's a power of x, things like this,
Mm-hmm.
and after it, it's a trig or an exponential, like e to the x, sine 2x, e to the 3x, cosine 4x. Anything that's got that shape to it, make f of x the power of x.
Why is that?
Well, the reason you do that is that in the formula, you're going to use f dashed of x. And if you start with a polynomial, isn't its derivative going to be a smaller, nicer polynomial? So each time you do integration by parts, the x cubed will become an x squared, and the x squares turn into x's, and then the x's turn into a number, and you'll be able to get the answer. Okay, you may have to do integration by parts 2 or 3 times, but it will eventually lead to the right result. So powers of x, you know, like x squared, you know, 2x squared, whatever, x cubed, those are good candidates. And once you know who f is, isn't the other guy, whatever the other guy happens to be, going to be your g?
Mm-hmm.
So you don't need to worry so much about picking your g, because if you can find the right f, g comes for free.
Could you theoretically get the same answer doing it the other way?
No, you wouldn't,
No?
because if you switch places, suppose I did f of x as this guy and g of x as that guy. What would the integral of g of x be?
X to the 4th over 4.
Yeah. And this guy, no biggie.
Yeah.
But watch what happens when I do the integration by parts, fella, right? It's going to be f of x, capital G, take away f dashed of x, capital G of x. And you get an e of the x and a 1/4 x to the 4, that isn't a problem, times an e to the x times a 1/4 x to the 4 dx. And if I tidy this up a little bit, do you see that the leftover integral is worse looking than the start?
Mm-hmm.
And you know, if I did it again, I'd get an x to the 5 there. And if I did it again, I'd get an x to the 6. It wouldn't be going anywhere nice. Wouldn't it just get uglier and bigger every single time?
Okay, so you just want to make it like smaller and smaller progressively.
Right, you want the f to be chosen so it gets simpler, right? Smaller and smaller.
Okay.
That's right. Now, when there is only one function,
When there's only one, the f of x is just that one, right?
yeah, you don't have a problem with that choice then,
No.
right? Okay, so I need to get into that. And then you have a group of questions where they ask you to do the u sub first. So you do the u sub first, and then it'll turn into something that looks like this, or I don't know, maybe something that looks like that. It'll turn into something that you can deal with.